All right, hello everyone. My name is Alan. I am a rising senior, and I am the electromechanical lead on Team 930.
My name is Greg Bilodeau. I'm an alumni of Team 930. I was on the team from 2007 to 2010, and I've been mentoring since then. So this is, I think, going to be my 16th season. I lost count. And today we're going to talk a little bit about strategic design and sponsored by Thrifty. So I said, you guys, as you're coming in, we've got some giveaways over there. Feel free to grab on your way out. And they gave us a sampling of parts here for you guys to check out and play with. They've got some stuff that they haven't quite put on their store yet, which is really neat. Some tube blocks, and we'll talk a little bit more about these in the middle of the presentation as it pertains to the presentation. But super thankful for them for providing this stuff and sponsoring the competition itself um, to help out.
Yeah, so first we're going to talk about what is strategic design, how you can set goals and understand the costs of these goals. Also, analyzing the resources your team has, finding what is good enough for your team, and then how you can use community and COTS parts. And then we're going to dive into a case study on 930's 2023 elevator, and then also the 2023 intake. And then we'll wrap it up with how you can retain design knowledge for future years.
Can you guys hear Aylin in the back? Just making sure. Okay. I have bad ears. Um, and before I go on here, there are a bunch of strategic design presentations out there. Mike Corsetto from Citrus Circuits gives a really great one, and we're kind of going a little bit different than that one. We totally recommend you guys go check out the one from Citrus. This one is a lot more about the process around it. All right, so strategic design. What is it in the context of this presentation? So it's about bringing the right robot to the field. What that means is different for every team. As a team, you are going to be setting goals for what you want to achieve this year. Do you want to have match performance? Do you want to have award performance? Do you want to find that niche as that third robot? Setting these goals as your team and then performing and then bringing that robot to the field. It will require an in-depth understanding of your team's resources and a strategic application of those resources. Every team has got things that they're really strong at and things that they need to work on. We'll talk a little bit about some of ours later on, but understanding those and being able to apply them appropriately for your goals. And then managing and evolving priorities based on the now of your robot. So what this means is every point during the season, the priorities are going to shift for your robot. Every day, things change based on what you learn about your robot that day. I've been saying that part of the build season process is almost discovering the robot that you've been building, understanding what it can do, what it's having trouble with, how it can be improved. And so your priorities for the current day, the upcoming week, should be shifting to match what you're learning. You may be learning that the robot is really strong or has a really fast and simple elevator, and so you should be maybe prioritizing to make that more efficient or shifting your priorities because you don't need to work as hard on the elevator. It's already working really great. Maybe you need to shift to something that needs a little bit more time, a little bit more love from your team members. But you're always doing this with your goals in mind, what you've decided on as a team, and making sure that your robot is kind of growing as a whole. I'll talk about it a little more, but later on in the presentation, but making sure that your robot is moving forward as a whole unit. It's not one-sided. You don't have a ridiculously good intake, but your drivetrain isn't assembled yet, or vice versa. Your drivetrain doesn't have awesome auto routines that are fine-tuned to the perfect level. You've got it in 13 seconds, and it has nothing on top of it. It's just a drivetrain. You've wasted a lot of time fine-tuning in autonomous mode when it's all going to change in a week when the top half of that robot gets attached. It's making sure that this robot grows as a unit.
So one of the first things you have to do is you have to be able to set goals and priorities, and those goals are the guidelines in which your team will follow and make decisions. You need to set them as a team and commit to them. So a way our team does this is we have a goal retreat for the beginning of the season, and our leads discuss what we want to accomplish in the season. And before the 2022 season, we decided that we wanted to go for the Autonomous Award to complete the hexafecta of the robot awards. And we, as a result, our robot was very heavily focused on the autonomous. So we had a bunch of sensors. We had a lot of focus on our autonomous routine. We had metal sensors on our elevator and made it fully autonomous. All of those things allowed us to eventually get the autonomous award. And then, so those goals will drive your priorities. So, like I said, with going for the autonomous award, you're going to prioritize different things on your robots, So that will shift at every point in the season, every single day, every single moment, basically, and it's going to eventually bring you closer to those goals. So, and then every goal you make is going to have a cost. It could be time, it could be materials, money. You have to balance those things. But you also have to wonder if you spent one time on thing or you spent money on this, does it prevent you from doing something else? Um, and so spending and understanding those costs is very valuable.
Yeah, Elon's talking about the concept of opportunity costs. So if you have your lead designer spending all of their time working on just designing an ultimate drivetrain, could that lead designer be spent better elsewhere? Especially with the advent of swerve drive as an example here. The drivetrain has actually gotten a lot simpler to design. You make a square, you plop those modules in the corner, and you're done. But things that are different every season require a bit more experience behind the designer there. And so where does that opportunity cost that you're approaching? So analyzing your team's resources, application of your resources will define your team's success. And so like I said earlier, understanding your team's weaknesses and developing strategies around them is one key skill to bring yourself closer to success. And I'll use our team as an example here. For about 9 seasons, 9 seasons, we built out of a church basement. Our largest piece of machinery was a drill press from Harbor Freight, and the chuck kind of wiggled when you tried to drill holes. And so we couldn't do anything accurately. The first few seasons there were interesting. So we decided to put our focus behind our CAD. And to enable this, we, as a team, found a sponsor in Waukesha that would fabricate sheet metal for us. We could send them stuff, and they had a 5-day lead time. So we'd send them CAD on Monday, and usually by Thursday or Friday, we would have parts in hand. 5 days in a 6-week build frame is a long time. For context here, this was back when you had to bag your robot. So you got kickoff January 6th or whatever, and like February 21st, something around there, you had to be done with your robot. So 6.5 weeks. Because of that 5-day lead time, and because we were a team that built 2 robots, our entire season was planned around that. Basically, there was a whole scheduled around it. We had to have the CAD done by the Monday of week 3, because then we would have the first version of the robot in our hands the Friday of week 3. So that's actually what this picture here. I've got a series of pictures here. This first one is that Thursday of week 3. I was picking up the parts in 2016, and I took a picture because I was really excited that we finally got our parts. This is me in the car, the parking lot of the place, picking them up. So that was Thursday. This was end of day Saturday. We had to basically scramble to put this robot together because parts needed to then be sent out the following Monday. So basically 4 days after this for the final robot. So we had to assemble this thing, put it together, test it to make sure we did everything right. 2017, we didn't. 2017 is kind of why we shifted off of this. It was the wiffle ball year, and the CAD for the wiffle balls was bigger than the wiffle balls actually were, and nobody on the team verified. And so we did all this. We put the robot together, and we go to put a ball through it, and just nothing touched. No compression on anything. So this was end of day Saturday, and then we met on that next Sunday, the next day, as well this year. And so getting it driving and testing it over one of the 2016, if you're not familiar, was a lot of just driving over weird things. So this was Sunday. We sent out parts then that next Monday. There wasn't a lot to change on here. Back then, we powder coated our robot, And so that took another 5 days of lead time. So if you're keeping track, we sent out the full robot Monday of week 4. We got, I found pictures, I didn't put it in here. We got the powder coated parts Thursday of week 6. So basically a week to then build, assemble, and bag that robot. Back then, the competition robot never got tested before competition. It went in the bag, wired, and we opened it up at competition and hoped it was actually wired. But this is an example of how our biggest weakness was tooling. We just didn't have the tools to make anything well. And so we shifted a lot of our priorities into CAD. These days we have access to a lot more tooling, but that shift from basically minimal CAD to full CAD has kind of changed the direction of everything we do here. So if you take a totally tangential thing from the side, CAD your robots. This is the slide I swapped, so now it's yours.
So, like Greg said, if your team does not have the capabilities of fabricating your own parts with accuracy, there's a lot of options out there for you with commercial off-the-shelf resources. There's, for instance, ThriftyBot here. They have a bunch of components that you can purchase with a lot higher tolerances than you could ever probably machine. And so whenever you're looking at creating a part, you have to ask yourself, is it more worth it to purchase something, or is it cheaper and you have the capabilities to fabricate it? There's tons of resources. There's the EveryBot, which we'll cover in the following presentation after this. There's First is doing a kit of parts robot next year, and there's also a ton of kits, like there's climb kits, elevator kits, turret kits.
Things like Alan talked about before, understanding where you're spending your money, your opportunity cost, where your opportunity costs lie. A big part of it is in cost. So there's like an elevator kit that they sell, and we actually will talk a bit more about that because we utilized it this year. But another part is sometimes there are, like, if you're like us, back then we didn't have a lot of we had a lot of tolerance issues with the chuck that wobbles and hand tools and everything. These days, a lot of these companies sell things that allow you to have tolerance issues, but be able to still make parts that have a nice tight tolerance. A lot of these things, for example, are you just drill like a clearance hole and then you can pop, for example, like a bearing hat around it, and it'll actually keep a tight tolerance on your bearing so it's not wobbling. Or these, you again drill a clearance hole and then you just clamp this to your 2x1, for example. A lot of cool things that allow you to be able to make a robot with hand tools that you didn't quite have. And then, yes, of course, all the cool, really spooky crossbow kind of looking pieces of machinery. But a lot of people use this style from either, I think in 2022, what was it, like Andy Mark had them, Thrifty had them, everybody had something like this that you just bought because they worked. All right. We took some pictures before we knew what we were going to have on the table. I think almost all of this is on the table except the bearing block or the bearing for the Max spline, which is out, and we're using them on our practice robot this year. We love the Max spline from Rev. Big win. It's just takes a little bit to like wrap your head around how it actually works. But after the presentation, if you want to come look at any of this, we won't put it away. Of course, there's goodies. All right, so a big component of how we operate as a team in terms of decision making across the whole thing is finding that good enough at every stage of the build season, every stage of the season. And this is a concept of not going too far too soon. Okay, so at some point you're going to have to choose between continuing to optimize a feature like an autonomous mode or an elevator speed versus moving on to something else. Learning how to determine when something is good enough now and you can improve it later is an important skill, because there's always going to be something you can improve on, but the gains you get are the diminishing returns over time, right? So for example, what did I put up here? Oh, I just put some questions, that's fine. Like, when should you buy a component instead of fabricating it? When should you be fine-tuning an auto versus, so when should you be like, I'm going to make my 3-ball auto and I'm going to spend all my time on that and totally neglect a balance auto, for example, this year? When do you pause for a moment and let the rest of your robot catch up to where you've gotten one of these components? And this is, I'll have an example here, and this is where we start to have some audience interaction. This is fun. When should you stop fixing what broke in the last match and make sure your robot gets to the next one? So 2019, we showed up to Midwest Regional, our first event. We went to wait. So we showed up. We knew that the end game hadn't worked yet. Okay, so I'm gonna set a little bit of a stage here, and then I'm gonna ask your guys' opinions on what you would do. Okay, so the robot went in the bag exactly as I described before, having run for about 10 minutes, and the end game didn't work at that time. End game, just like every year, happens to be really, really critical at your very first event. So it didn't work at the time it went in the bag. We showed up to competition, got on the scale, we were 7 pounds overweight at our first event because, again, robot just went in the bag 10 minutes after it was built and wired. No time to weigh things. Who cares about that? So it is now probably noon on Thursday because we had finished putting together the rest of the end game that wasn't done at the time. We needed to test the end game, which is critical for seeding high at a week 1 competition, but we also needed to be legal. All right, what do you do first? What questions do you ask that help you inform a decision here? And we can make this really easy. Who would test your end? Oh, you have a question? Sure.
So basically, my thought process then that would be, is it more critical to get that end game down first, or just to get it on the field to score as much as you possibly can before?
Sure, that's a great question that you would ask. Yep. All right, we're going to do just like an easy one. Will everyone raise hand one way or raise their hand another way, or you can just not participate. That's cool too. You would test your end game first. Okay, well, the person who was on the team in 2019 can't raise their hand. You would get underweight first. Okay, one more piece of information. The robot that 10 minutes that you tested it, the end game before it went into the bag, the end game snapped. It was not strong enough. Okay, so the stuff you put on there now is reinforced was stronger. Does that change anybody? No. Okay. So that's part of it. That's part of it. So what we did was we went back to the pit and we said, okay, we're overweight. We need to lose weight. We're not going to drill holes in the robot just yet. We brought it to the practice field, tested the end game. It broke again, and we took it off. We were underweight. That end game probably weighed 20 pounds. So there was like a 50-50 shot that it was going to work or it wasn't, and it wasn't worth drilling holes in the robot if I could just know that I could take it off without regrets. And that worked. Downside is, as always at Midwest, the one team that could do the end game consistently seeded one, and they couldn't do anything else, but they picked us, and yeah. So being able to step away and learn when to move on is hard, but sometimes you got to look at the bigger picture of how do I bring the best robot to the field that I can at this moment. Okay, so we're going to talk a little bit about applying this for a couple of case studies. The first one we're going to do is the elevator for this season. So this little GIF here was kind of our original concept a day after kickoff. We had decided very early on that we wanted to do an angled elevator because 930 has done elevators in the past. If Aylin wants to play with this one for us. This is a big part of the question. 2018 and 2019, we designed our own elevator that proved very successful for us. It used kind of an unorthodox design here. The bearings are just plastic UHMW blocks. But we were good at elevators. And so, week 1 of this season, we were like, I hope we're still good at elevators. We had to decide, though, did we want to use this guy, basically continue iterating on it, because we competed with it in 2018. This was when we were still in that church basement. So these plastic blocks here, we had to do in-house. And so we did them in-house by buying 3 pieces of plastic from McMaster, drilling holes and bolting them together, because those pieces of plastic are little H's. And so we just bought the pieces, bolted them together. They had tolerance issues. Everything wobbled because it's bolted on by kids and mentors who couldn't drill straight holes in the right spots. So 2019, we moved into a new school and we had a CNC, and so those ones here are CNC'd. Everett in the back there and one of our mentors spent probably 2 weeks just trying to CNC those to a nice tight tolerance. They spent a lot of kind of the costs that Alan was talking about, a lot of student costs, a lot of machine time costs. There was no money cost. Plastic is cheap, especially you just buy a big bar of it, and then they just spent 2 weeks running it through the Haas, trying to get it to be tight. If you don't know, plastic is really annoying to machine. It flexes, it expands, it moves. It's a pain in the butt. They spent probably 2 weeks, but they got it to a point where, like, this is just the nicest elevator I've played with. The one on the competition robot went to play nearly 100 matches. I think there's like 88 on Blue Alliance, but Blue Alliance doesn't have all your off-season competitions. And then, of course, all the practice time we spent on it. All we did, as far as I remember, is lubed up the elevator basically every competition. The ropes on there had to be tightened a bunch. The ropes were probably the weakest point on this guy. Great elevator. We loved it. Everybody on the team still liked it. But it was also 4 years ago. So everybody on the team that worked on it that's not a mentor is kind of gone. And we lost one of the kids who spent all his time on it to more robotics. So, yeah. So we had to decide, did we want to use this, redesign it? Which also, if you notice, it's got everything's kind of horizontal. All the bars are horizontal. We're not 148. We didn't make a really weird elevator in 2018, and then 10% of the field copied it for 2019. We have just us as design inspiration. So if we were going to make this an angled elevator, we had to figure out, is the plastic going to hold to the forces now being against it? Or are we going to use a COTS solution? Because this year, lots of COTS elevators came out. Thrifty has them, Rev has them, West Coast has them. Everybody has elevator bearing blocks now. Andy Mark has them. What do we do? So for our elevator, we decided the cost was low, the design time was medium. We didn't have any inspiration other than ourselves, so we'd have to figure out and consider how everything's going to act at a 45-degree angle. Also, the space cost was pretty big for this because it's all horizontal, way wider than most elevators. Machine time had a lot of risk with it, a lot of potential to be way too high because, again, the student who worked on it graduated, has moved on to other teams, better teams, and the mentor is now in California, not over here to spend all his time just solely focused on the Haas. So the machine time is risky. Elevators just need to work, right? They are like a support piece of your robot. They're like the drivetrain. They just should work. They shouldn't be temperamental. They shouldn't require a lot of like time and commitment. They just need to work. So we kind of considered it high risk, low reward. So we kind of went to a middle ground. We decided to still design our own elevator, but use COTS bearing blocks. We ended up using the Thrifty ones, which I'm noticing now he actually didn't send us any besides what's on that. So that's cool, I guess. No, it's fine. I'm just joking. If he's watching this. So we decided to design our own. We ended up modifying them a little bit. The robot's not in here, so you can't see, but we wanted to have an open top and an open bottom to our elevator instead of all these cross beams that you see like on this one and on that one. So we decided to just basically add little struts. Ooh, don't touch the smartboard. That fully contain the elevator. But that allowed us to basically get the elevator just working and focus on more important things. Let's see if this still works now. Cool. All right, part 2 now, and this is more audience interaction here. So it is February 11th at 6 p.m. For all the Wisconsin teams in here, this is a week before Sussex. This is Saturday. Sussex was February 19th this year. So for our Illinois team, and I think that's the only one in here, Sussex is our week 0. So our week 0 competition. We have a week. The electromechanical team has dropped this robot onto the practice field and said, all right, this is yours, programming. Have fun with it. And it's there. And so there are a bunch of things. And so this list that we've got over here is kind of the things we need to do now. We have a week to do them. We need to find all of our positions for intaking and scoring. If you've seen our robot this year, it's complicated. It's got 3 degrees of freedom, which a lot of you guys do, so you might know. Elevator goes up, arm goes up and down, wrist goes up and down. We have to verify all of the positions for all of those. We have to make sure they don't run into each other while they're traveling. No safety on this robot. We need to make sure that this intake works. We need driver practice because driver practice is like one of the core tenets of success. A faster elevator is a better one, another core tenet. If your elevator is faster, you just have one less thing to worry about. And we need to find the weak points in the design so they can be fixed. So basically, we need to verify a bunch of things, we need to drive a bunch of things, we need to test, and we need to break a bunch of things. And fun fact here, this list never changes. Throughout the entire season, you're always going to have this list, and it's always going to grow. Always more bullet points. And so the next question where I ask, what do you do first, is always a question you're asking. Luckily, later on down the season, it gets a little bit easier because like all of these things are critical things. Later in the season, there's usually only like one critical thing, two critical things you have to balance. What would your plan be here? So again, it's February 11th. We have a week to basically verify. You also, it's hard to see in here, but all of this here is like brown cardboard looking. That's all just, it's literally just cardboard. So about half of this, the entire upper half of this robot is attached by 3 bolts on each side on 2 giant pieces of cardboard. Okay, so it's not finalized at all. There's nothing, this will not survive anybody. If mosquito came and hit us, that whole thing is flying like 20 feet.
The driver's in the other room.
Good. I'll make fun. No, I'm just kidding. But either way, all right. What of this list here would you think you do first, or would you guys? This is totally an opinion. There's not a right answer here. You can throw out anything. What did you guys do first? Everybody had a robot that had to do these things this year. Maybe it wasn't an elevator. Maybe it was you had a 971 arm that had 3 joints, but everybody had to do these things.
The quicker you break it, the quicker you can figure out what needs to be fixed.
Yep. So breaking it is very important. I understand that. Allison wants to say things, but she's letting the audience.
I'm trying to like telepathically tell my kids to actually say words.
Yes, sir.
Don't have to.
Finding positions. Okay, you got to verify your positions. The second part of this is like programming has had this robot already. They've got logic there, but they have no PID yet. Like they know their PID will work once they put in the correct values, and they don't know what those are. Okay, all right. So options, yeah, focus time on elevator, making it fast, focus time on driver practice, focus time on breaking it. Couple of those. We'll just skip past this to the fun parts. So factors we considered, and I've got a bunch of pictures next, because this will actually be fun. When in the season is it? Because like I said, that list never changes. So at this point, you figure out which is important today, not what's important tomorrow. So for example, it's not important today to make that arm go as fast as possible. It's going to break, like Jeff said. That robot is going to change significantly, and PID tuning, for those of you that are aware of it, is sensitive to big changes in your robot. So if there's big changes, don't waste your time. How do we be competitive at our next event? So in this case, our next event is Sussex. So we just need to be enough to be competitive at Sussex, which really means we need to get value out of Sussex. Yes, exactly. Move. The word will change for your week 0. Really, for the week 0, it's how do I get value out of being there? Okay, so if the robot just goes there and you're just fixing it the whole time, could do that at your shop. So we want to prepare to not have to do that. How much do we want to learn before we break it? When do we plan on iterating? What do we plan on iterating on next? So in this case, we planned on that intake. That intake was our biggest question mark, and we need to know, is it changing? Is it staying the same? And what upcoming changes are going to invalidate anything we learn now? That's kind of the idea of like, if that top half is changing, don't waste time PID tuning. So I've got some pictures. So like I said, February 11th, that picture was taken at 6 p.m. The times, there's about 2 times a season we meet a little bit later than usual. One is when we're at big milestones like this. The other is like before Sussex. So 10 p.m., we started finding PID values. It went really well. Nope, wrong button. About half an hour later, they actually found them for, like I said, what was good enough for today. So for Sussex, it needed to be able to pick a cube off the ground and score it without Brian running up and putting the cube in the intake, right? Because you can't do that you can't run on the field at Sussex. It drives, and it's going to score it. I promise this isn't going away. Here we go. Watch Brian. Here we go. He's going to get so pumped. This is the first piece it scored. And then half an hour later, we're like, okay, it scores. Let's get driver practice. Those giant pieces of cardboard lasted about half an hour of Ryder over here trying to intake pieces. But really, this was driver practice. This is also validating that intake. And the reason he's doing so much shaking is because that intake had to be so perfectly aligned that he was having to kind of strafe like this and just harmonic. It just kept going and made bigger until it snapped. The GIF goes even a little bit longer. I cut it off, but there's a great picture of our program manager giving like the gym face where she just turns to the camera and just stares. So, okay, so we figured that out. We know that we need to fix the prototype parts. We know that we need a new intake. We know a few things, but either way, 7 days later, all right, it's kind of hard to see. There's actual metal now attaching the elevator to the rest of the robot. There's a new intake because we just did not like how the other one was performing, and we had, at this point now, a day before it needed to actually do something. So we went with what we ended up staying with the wild staying intake because it was just a better use of our resources. It's programming new to this robot. So this GIF is just showing that everything is still really, really slow. Okay. So what is our next priority now? We're moving the robot forward in an equal kind of path. Everything is growing together. Mechanically, it is at a better place now, so we need to make sure that programming is at a better place. So the next thing we did was making sure, because we're preparing now for our week 0 where we need to get value, we're making sure it can actually score. It doesn't need to score fast, it just needs to not explode every time it moves. Okay, and so yay, look at that. Aylin's super pumped. That's excitement for Aylin. Super excited because it scored and it scored high. Everything moved, it went up together. It didn't do it perfect. It would automatically just spit out the game piece about a half second after it reached there. So if the driver wasn't there in time, too bad, but good enough. And then a couple hours later, like, all right, full system test, make sure everything works. Yay, it moves slowly. I didn't slow anything down. You can tell by the signal lights that you can kind of see there, because sometimes the frame rate is different. But full system test now is you just prepare to get value out of Sussex. So everything worked. It's great. And so this now progresses through the entire season. You have to keep your priorities kind of spread out across your robot and moving forward in lockstep. You don't want anyone getting out ahead. And so one example of how these priorities shift together is like you already saw this GIF. This is like the Sussex scoring speed. It was good enough for Sussex. What did we need at our first competition in Midwest? After we came back from Sussex, we said that's a little too slow. So we basically doubled the speed of everything here. Still kind of slow, but good enough for week 2. We came back from Midwest and we decided that, boy, that was still kind of slow because there was some tough competition, and tough competition's only going to get harder throughout the season. There's my button. And so we decided Wisco speed, where everything now, again, we just kind of doubled it. But it was investing time in PID tuning, which is not a simple process. You can't work on the robot while that's going, especially with an elevator, you're going to lose hands. So it's just focus time here just for PID tuning, but it was necessary to keep the robot moving forward together in competitiveness and in reaching towards our goals. I think that's my stop on the elevator. Now Aylin gets to talk.
It's the down arrow.
Down arrow, yes.
Okay. So now let's take a look at the 2023 intake. So this is the ground intake, so separate from the one that's on the arm. We wanted something that would be compact out of the way of the elevator and allow us to pick up game pieces from the ground. So our original thought process was that we wanted to pick up tipped cones and then flip them up and bring them to our manipulator where we could then score them. So we had used 4-bar intakes in 2022 and 2020, so we had the experience of that type of mechanism. We'd also had gained some experience with using a motor to extend the intake versus pneumatics, since at this point we had no pneumatics on the robot, so we wanted to stay away from that. And we also knew that since this was a completely separate mechanism, if something failed with it, we could still rely on the rest of our robot, which meant we could do iteration throughout the entire season. So starting with our first version, You can see on that GIF over there, we had 2 rollers that would grab the flange of the cone, and then we used another motor, you can see over here, and that would rotate the rollers and rotate the cone upright so that we could then grab it with the manipulator. And we had a couple of issues with this that we noticed. It took a lot of torque to move the cone. There was a lot of force on that Neo, as well as it took a lot of programming or driver inputs, and we didn't have the time at that point. This was around, say, week 1 of competition, and we also just realized that it was too complex because you had to worry about extending the intake, you had to worry about rotating the rollers, you had to really worry about running the rollers, adding current detection. So we decided to pivot to something that was simpler, but still be as effective.
This was prior to our first competition.
Yep. So what we looked at doing was we added a back roller to our intake and added a polycord to reverse the direction. And that way we could intake cubes, and we had a little cover for it. And then we would just eject them outwards, and it would be just a hybrid-only intake. So it would intake it, and then extend out, and outtake it into the hybrid area. So it removed a lot of the complexity, because now you only have to worry about extending the intake and rotating the rollers to bring in the cube. But the issue was at this point in the competition, even though the link RP, by going for those bottom hybrid nodes, would be valuable in getting the link RP, we noticed we needed a lot more points to win the match. So we couldn't just do hybrid nodes, and we ended up prioritizing the higher nodes anyway. And so this intake never really got used in competition as a result.
I'd say if you paid attention, I think we used it for 2 practice matches at Wisco before we came to the conclusions that Alan Kane was just talking about.
Yep. And yeah, and we were also, because we were prioritizing those higher nodes, this never got used, and we wanted to be able to still use that space. So what we ended up implementing it for was for champs, and we removed the cover of the intake to allow a direct transfer between the intake and the manipulator. So we'd bring the manipulator down, and we'd grab the cube, like you can see in that GIF there, and that allowed us to very easily pick up cubes from the ground right at the edge of the loading station. So we could do very fast cycles between the community and the loading zone. And we could still score them high, we could store them mid, and we could store them low.
Kind of like we've been talking about here. So this video was like 2 days before we left for champs. The garage might be open because we were packing the robot or packing the rest of the trailer. I don't remember. Well, the garage isn't open. But at every point during the season where Alan was highlighting the rest of the robot, there were things that were more important and better use of our resources. The opportunity cost was too high to work on the ground intake. For example, like getting the elevator to go faster, getting more autonomous modes. Autonomous modes was the big one. We kind of neglected autonomous modes a little more than we should have at the beginning of the competition season. And so it wasn't until our 3rd event in week 6 where we actually had an autonomous mode we liked. And so after that, then we had, okay, the diminishing returns of everything else is lower than this. So we actually had time to focus on this and figure out how to make it work.
So yeah, so there were a couple of things we learned from this. Because it's a completely separate mechanism from the other parts of it, if it's not working properly, it's not as big of a deal. So you can continue to make changes to it throughout the entire season. So we started with wanting to do floor cones, but then we transferred to hybrid cubes, and then eventually all cubes from the ground. And we were able to do that and iterate because it was a separate mechanism. And just that first cone flange grabber mechanism, probably if we had invested more time in it, it could have worked, but it would have taken a lot more programming, and we didn't have those capabilities at the time. So being able to switch to a more simpler solution turned out to be just as effective in the long run.
Honestly, if we'd had more resources, that initial design, I think, in its final version is probably the best one, but we didn't have the resources to make that. You look at the highest level, it was always about picking up, at the very top, it was picking up those floor cones, so you weren't waiting on the driver station. So hindsight now, it's like, if we'd had the time and resources, that would have been valuable. But we evaluated what we had and what we could apply, and got we were kind of like behind the curve at every point until the very end. We're like, okay, this is good, but kept us going. And like Alan said, this part of the robot wasn't the essential part. It was kind of like an ancillary, nice to have. It's like the icing on the rest of the cake there.
Finally, we're going to talk about how you can retain design knowledge for future seasons. So, of course, through all of our iteration, we didn't have perfect designs. And the example I'll give is at IRI this couple weeks ago, the Neo 550 on our intake right here has a belt running to it to the roller. It sheared during one of our elims matches, so there's no shaft on it anymore. And it's fairly well documented that if you have constant tension on the belt, the Neo 550 can be very prone to shearing. So we wanted to take a lesson and learn from it. We would learn from it, but also we wanted to make sure that future students and mentors did as well. So what we did is we have a design review checklist. So before any parts are fabricated, the design is reviewed and they run through a checklist of like, do they have the correct thickness in the material? Do they have bearing retention holes? And is the motor in a good location? And so what we did is we attached a presentation, link to a presentation onto the side of it, and then in that presentation we detailed some of the possible solutions and the issues we had with that design, so that it can be learned for future seasons. So before I switch to the presentation, what are some ways that we could have had a different design to prevent that shaft from shearing?
Protecting the shaft is important.
Mm. Yeah, so the Neo 550, the front shaft spins, but also the back of the motor spins. And the back of the motor actually has mounting holes that you can use to your advantage. So an option for us could have been we could have put a pulley on the back of the Neo instead of the front, and that could have prevented it. We also could have maybe not used a belt. We could have used like a gear pinion because that wouldn't have put tension on it. It should have been in a more protected position because that intake was extended out and hitting other robots and hitting walls and stuff.
Just open to the world.
Yeah.
2 feet outside your robot.
So here's the presentation. You
That's
can see
cool.
that we have a description of the original design, and then we talk about the issues we had. So we said that it sheared, and then another issue we had is that electrically, when it was wired, the connection was soldered, so it was directly soldered to the robot wires rather than having a connector in it. So when we needed to replace it between elims, we didn't have a way to quickly just unplug the motor. So in the future, we're going to try to put connectors on all of our motors that we can switch them out, and that it was put in here so that we can remind ourselves in the future.
This particular part, the connector being soldered, bit us twice because it happened at Champs in the first elim, and then we didn't fix it, and then it happened at IRI. And so we are in your little like 15-minute break between matches are trying to solder the little sensor cable wires in the middle of our robot with someone with a flashlight, and some random team, I think some guy from 118 walks up with a torch soldering iron. Like, here, use this. And it's like, oh my God. But like along the lines, and some of the cool things here, he sent some things that they're still working on. And so I had no idea what the box was going to have. And so this little guy, I think, is probably the most interesting thing because it's got a hole pattern that mounts to the back here. It's aluminum. A hole pattern that mounts to the back. And then it's got a thing for a hex shaft. And so you put a bearing over here. That's probably your next failure point, is that now you're like putting a lot of torque over here. So you probably want to have a bearing to capture the other end, but suddenly now you've got a half-inch hex 1-to-1 on your little 550. That's kind of cool.
The shaft is kind of like sticks out.
Yeah, or you use this motor right here, where you shear it right off. There's no risk. But I think that's what more you guys did on your arm initially was you were all belt driven off of the butt of the 550.
Yeah.
You could put like a snowflake, you know, a spiral. Yeah, exactly. You have all this opportunities.
I went back to Donahue with the product idea to have decorative items on the axle.
There we go. Decorative shaft decorations.
It's not a nuclei on the shaft, but we don't mind.
Yeah, and then in this presentation, we also put some examples of what other teams did. So you can see where they had the Neo in a more protected position.
They actually protected the Neo.
Yeah.
Concept. Keep going, sorry.
All right.
Oh, okay.
So in conclusion, strategic design will look different for every team. It depends on the resources you have, depends on what goals you want to pursue. And like I said, those goals will change throughout your entire season, probably every day. And you need to constantly make a decision of what are you going to prioritize in order to complete those goals. Community resources and commercial off-the-shelf components, like for example, ThriftyBot, are really helpful for instead of putting extra weight on your team, you can just purchase those components and just be as effective.
Mm-hmm. Yeah, so that's kind of the bulk of our presentation. Do you guys have any questions? Yes.
What time is it?
99:90. It's not 9:30 anymore. It's also not even 9. Yep. Other questions? Cool. Yeah. So there's about 10 minutes to the next presentation. If you guys, I think, is that QR code a survey?
Yes.
You want to grab that QR code? Because 20 people surrounding that table is just going to be terrible. So why don't you just like prop it up right here? Look at this pretty little stand that they sent us. So we would really appreciate if you guys could take the survey for this.